Okay, so we're gonna work out a revenue model. Now, in the support class, just a little while ago, looked at one in detail, a lot of explanation. And there were a few errors that I made, as I always do. Okay, but if you watch that, you can see how I'm always thinking about what makes sense. Okay, so at every step, I kind of say, okay, is this going to work? Does this make sense in terms of what I've already seen? And that helped me discover 2 or 3 errors that I made in the process. Apart from any errors in mental calculation, some of which I did a little more quickly than I would have if I wanted to be really accurate, okay? But most of them were in the right ballpark. Okay, so let's just look at this model. Okay, so we have X equals the price we charge. And Y equals the number we sell. Now, from our experience, we know that if we sell for $8, and we're going to sell 12,000 of those things. Okay. And if we charge $20, we're only going to sell 5,000. Now, can you tell me quickly how much money we're going to take in? If we put the price at $8, how much money are we going to take in? If we put the price at $20, how much money are we going to take in? In other words, what's our revenue? That's how much money we get when we sell these things. Okay. Okay. Well, if the price is 20 and we sell 5,000, the revenue is 20 times 5,000 is 100,000. Okay. I mean, it's easy. 20 times 5 is 100, and it's 5,000, so it's 100,000. Now, if I multiply then price 8 by 12,000, revenue is 96,000. Okay. So you might get the idea. There's not much difference between 10,000, between 96,000 and 100,000. Okay. So in this whole price range from 8 to 20, you might start thinking, well, it doesn't matter much what I charge. Okay. It's going to turn out that it does matter. And that somewhere between 8 and 20, there's a price that's going to give you the maximum resident revenue. Okay. Does that make sense? We go from here to here. Some price is going to give us maximum revenue. Matter of fact, we could say, this is incidental. I hadn't planned to do this, but I'm going to do it anyway. Price of 10. How many would you sell at price of 10? Okay, well, I'll say 10 is 1/6 of the way from here to here. From here to here, we go down 7,000. 6 goes into 7,000, about 1,160 times. So we'd be selling a little less than 11,000, which would be 110,000, less the 1,600. I'm gonna say it sells 10,830. Question mark on that. That's a no calculation. And sign into me. The revenue is around 108,000. If that's right, that tells me that the rate of change of the revenue, well, revenue increases by 12,000 when the price goes up by $2. Okay. It means the rate of change of the revenue with respect to price is about 6,000. Okay. So the revenue is going up pretty rapidly here. This is an indication that we're going to be able to get much more revenue than just that 100,000. Okay, we might even get 120, 130,000 if we can maximize this model. Okay, so that's just kind of a side note. But it's kind of important. When it's a rate of change thing, we look at the rate of change of revenue with respect to price, just based on a ballpark estimate. But in a minute, we're going to have a function where we can actually figure out those average rates of change. Okay. Not sure we're going to actually do that. We're kind of focus on the model. Well, the first thing we want to do is when I say, well, what's the curve look like? You know, as I sell more and more, as I raise the price, I'm going to sell fewer. Okay. Well, we're going to take the simplest possible model. We're going to say, okay, let's assume that the number sold is a linear function of the price. So we assume a linear model. And now we want to find the equation of the straight line between these 2 points. Okay. Two possible forms. Of our equation. It doesn't matter which form we use, we're going to come up with the same result because these two would be completely consistent. Okay. I'm going to use the second form. Now, in the prep class, we did a similar model. We used slope-intercept form because we've got a fundamental triangle standing right there smiling at us, okay? And we can see that the rise is negative 7,000 and the run is 12. Okay, negative 7,000 over 12 is about 5,833, I think. Okay. Slope be negative 5,833. Now, 583.33, okay. Nice. I think that's what we're gonna get for the slope. But I did that in my head, so dismiss it. Okay. All right, we use a second form. How do we use a second form? Y equals 12,000, x equals 8. So A times 8 plus B times 12,000 or change this one. Make it AX plus BY equals 1. A and B are flexible. Okay. Y equals 5,000. X equals 20. So A times 20 plus B times 5,000 equals 1. Okay. Well, we can rewrite these 8A plus 12,000 B equals 1. 20A plus 5,000 B equals 1. How can we solve these equations? We can put them into an augmented matrix. And we can reduce that matrix. We can do equation one divided by 8, we get 1/1500.125. And we get this. Okay, now I'm going to work this out without a lot of explanation because you all did really well with matrices, so I just want to refresh that. Okay, and then we do equation 1 here and equation 2 minus 20 times equation 1. This might be a little hard to read, okay, so we have 1/1500.125, and we have then 0 and 20 times 1,500 is 30,000, so we have negative 25,000, and 20 times 125 is 2.5, it's negative 1.5. I think that's right. Okay. Then we divide equation 2 by 25,000, we get 0, 1, and I think that's 0.0006. And 1/1500.125. I'm not writing out all the steps here. But then I do 15 times 100 this equation, subtract it from this one. So I'm gonna get 1, 0, 0, 1, and 1500 times 0.0006 is 6 parts in 100,000. 1 part in 1,000, so that's like 0.9, and I'm gonna get negative 0.775. 0.0006. Okay. Something there isn't quite right because I get a lot of stuff in my head. It's not all that far wrong. This equation would say that A is negative 0.775 and B is 0.0006. Now that value of A that might actually. Okay, so what I've done is I've used this form, which is a valid form for an equation with a straight line. I've got two simultaneous equations, one for each point. And then I attempted to row reduce this thing. Let's see if I did any good. This amount of calculations could easily put the wrong number zeros and stuff. I don't want to get too hung up on that. Just demonstrating that we could do the problem this way. This tells me that my equation is gotta get y equals six into this. He's gonna give us like 1, 2. If I get like 1, 3. And where's the decimal going to be? Got to go to 1 with 3 more places. So that number is a little wrong, so something went wrong over here. Now, right or wrong, and something went wrong with some of my calculations. I did them kind of quick and I did them in my head. You know how to reduce this matrix. So what I've demonstrated here is a way to get the equation. If I do it like this, it just doesn't quite work out right because my slope is correct, because I can look over here, see that my slope, uh, is gonna be negative 1300. Okay. I don't think. Seems pretty obvious. Okay, so now I'm gonna do the fundamental trial. My arrows on to make sure I don't miss anything bad off. My rise is negative 7,000. Minus 12. So the slope is about negative 567. No, it's not 583. Okay. So look what we've got. Slope is negative 583. When I did this, my slope came out over twice that rate. So again, something went wrong in my matrix reduction. Okay. You could do that. No reason you can't reduce this matrix down to this form and get the right numbers. You can also use y equals mx plus b. Got negative 583 here for the slope. So you got the slope, and then you just use one point on the graph. So good. So using y equals mx plus b in a fundamental triangle. And remember, on the exam, you're gonna have to make fundamental triangles and label them correctly. Make sure you know how to do that. Okay. And make sure you know what they mean. So I'll break some change. And now I can use one of these 2 points. Direction y. Using the point 8, 12,000, we get 12,000 equals negative 583x. Well, 583x is 583 times 8. It's not plus 12,000, it's plus b. Terrible about seeing something, writing it down, and I know I should be writing something else. So anyhow, we get b. Well, it's easy to solve this. That's going to be 4,800, but it's going to be 1,100 foot short, so 4,700. Here we get 7,300. And I did the wrong thing. You have that 4,700. So I get P about 16,700. Which is way better than Model question. It's about what I got here, isn't it? I just looked at that. Pretty much the same thing. It's 670 instead of 700. That's just a simple approximation error. So I don't know how that could be as far off. That could be right. It must be that I did most everything right. It's valid. It's not right. Okay. Some small error. Okay, well, let's see now. Looking at this model, what did I do? I said, I look at the graph and I say, no way that slope is negative 1,300. Okay. It runs like 12, the rise is like negative 7,000. 7 divided by 12 doesn't give me 1,300. Okay. It just wasn't going to work. However, when I did this slope intercept model, which is really the easier one to use in this case, unless you have machine reading, throw the augmented matrix into it, get your correct numbers right away. B is the y-intercept. The model is y equals negative 583 x plus 16,700. Now, does that make sense in terms of our graph? The y-intercept occurs when x equals 0. If x equals 0, y is 16,700. Here's our graph. Here's 12,000. Here's our y-intercept. Could that conceivably be 16,000 something? Yeah. Yeah. Seems reasonable. So I tend to believe this model. You see how I'm checking as I go on? You need to do that when you do these problems. I'm making mistakes. I knew I was going to make mistakes. Okay. I always know I'm going to make mistakes. So I'm always checking and thinking, is this consistent with what I started with? Or something that I got earlier. Okay. So that works. What's the x-intercept here? If this is 20, that's probably around 30 something, isn't it? Makes sense? Understand why I asked you to start doing estimates early in the course? People were not good at making estimates early. Some people were. I think it'll probably work. If I let y equals 0, I get x equals this over 583. Now 16,000 over 500 is 32,000. Okay. So the solution to this is somewhere around 32,000. Probably a little less than that. It should look like around 30,000. It comes out reasonable. Does that make sense? I check what the x-intercept of this would be and what the y-intercept would be. And I go back and I look at my linear graph and they seem to be just about right. Model gave me an x-intercept. Well, it wasn't going to be right. It gave me a y-intercept that was about the same as this one. Something was wrong with my slope. Okay. What came out of here was this equation. I solve it for y. I'm sure I get something much like, yeah, yeah, no, you know what? It's even worse than I thought. No, it isn't. Yes, it is. Yeah, it's as bad as I thought. Okay. Sorry. Looking at my numbers again, I thought I saw something. Wasn't going to help. It was going to be as bad as the other one. Okay, so anyhow, we got the model. Okay, what's the model say? And I'll go back. What did you do when you had just this point? Sell 12,000, you charge $8, you got $96,000, right? What did you do to get that? You multiply price by the number you sold, right? That's your revenue. So you multiply the price 20 by the number 5,000, you get revenue of 100,000. You need to understand that and kind of keep that in your head. Or write it down on paper and keep reminding yourself. Okay, price times number sold. Now, on this model, what's the price? Where is the price in our model? Okay, some people say this, some people aren't. Have this statement. What does X mean? It means X is the price, right? What does Y mean? Tells you right here, it's the number we sell. Now let me emphasize the importance of labeling your axes, so you can always look back at the original graph and see what things mean, because after doing all the calculations and analysis, making all the mistakes I make, I could forget, okay? So right there it is in my graph, everything. Slow, price we charge, coordinates, importance. Okay. So price times number sold, we look at the graph. Our graph told us it's already labeled on our graph. I'm just reminding us that's the meaning of X and Y. And that's exactly what we need to multiply. Okay. That's going to be X times Y, which is X times Y. Y is this. Okay. And that's the quadratic function. Now we know that our graph is going to look like this. Now, there are things we don't know about the graph. You notice I haven't put a y-axis on it because I don't know where the intercepts are. And I don't know where the y-intercept is. Actually, I do know, but okay, at least I know how to find it. So, how do you find the intercepts? To get the details, we find the intercepts and the axis of symmetry. And well, I'm going to say, R of X for revenue as a function of X, right? And that's revenue as a function of what we sell it for. So X is something we can vary. We can set the price where we want to. Okay, so R of X is this. And it's X there. Okay. If I want to set this equal to 0, which is what's going to give me the x-intercepts, I look at this and say, okay, I can plug into the quadratic formula. A is going to be negative 583, B is going to be 16,700. There's no C on there, so C is 0. I plug it in, I do all this stuff, right? We're going to have to do that when we get the profit function. But there it is. I can also say, well, look at this. Geez, I can factor out X. Factor out X, and I get this, which is what I got this from up here. Repeating something I already had. And this is going to be 0 if X is 0, or if this is 0, using 0 property multiplication. Now, without doing details of that division, I'm going to get 20. Okay, we already looked at the graph and saw that the demand function is 0 when X is around 3,000. Well, if the demand is 0, we're not going to sell any, we're not going to get any revenue. Revenue is going to be 0. So this is consistent with looking at the graph and say it looks like 30,000. I did a calculation. Let's just say it comes out 29. You can just divide 16,700 by 583. Okay. 18,000 divided by 600 is 30. This is a little more, this is quite a bit less than 18,000. This is pretty close to 600, telling me that probably just a little bit less than 30, but I'm just guessing. So, okay, so now we know that this would be the point. 0, 0. This would be the point. 29, 0. Now, normally we want to find the y-intercept, but the y-intercept, you plug in x equals 0 into any of these forms, and you're going to get 0. So you don't have an extra y-intercept, which makes it a little harder to estimate a y-scale. What's the axis of symmetry? Well, the axis of symmetry cuts this graph right in half, which means it better be halfway between here and here. Okay. Well, the axis of symmetry is x equals 14.5. So here again is x equals. 14.5. Every time I try to prove that, I mess it up. Approximately. A lot of room to write anything. I fell from my hands. Have a hard time here. Well, the revenue is R of 14.5. That means we put 14.5 in, 14.5 in for X. Okay. Now 14.5 squared is around 210. So that this times X squared is going to be about negative 10,000. And that'd be a little more than 10,000. So let's say it's around, I'm going to guess 6,200. Oh, wait, there's looking at this rather than this. And I think in two places at once. Okay, we got to plug X in here. So that negative 583 X squared is about negative 10,000. You multiply this by 14, or multiply 16,000 by 14, and you get about 200, 16, 256, 220,000. There you get 200. So that's 100,000. You get about 130,000. So, okay. Now, what you actually get might be 120,000, 125, 130,000, somewhere around there, because I had to do some mental approximations. But you plug that in your calculator, in your Excel spreadsheet, and you predict that if I charge $14.5, let's say, I'm going to sell what I get when I plug in 14.5 here. Okay, which should be around 8,000, something like that. And my revenue is going to be this. And all that could come out of here. I could multiply my 14.5 by this. This is what I'm charging. This is how many I sell, and figure out how many I'm going to sell. It's going to give me though this result. Now let's see if that makes sense in terms of the graph. What we just said was my sweet spot is X equals about 14 and a half. Okay, which is about halfway between 8 and 20. Best price is approximately 14.5. The number we sell is approximately equal to, well, here's 5,000, here's 12,000. Looks pretty much halfway. Halfway would be 8,500. And again, if we sell 8,500 at 14.5, well, 14 times 8,000 is 112. 14 times 8 is 112, that'd be 112,000. Another half, we get it up to about 116,000. And 14.5 times 500 is going to add another 7,000. It's going to be up in the 123, 124,000 range. Okay. Now I can see that from my graph. I figured out my best price from the quadratic function. It's a vertex, it's an axis of symmetry. Okay, because that's where the highest price occurs. The highest point of that graph is going to occur on the axis of symmetry. So that this point here should be about 14.5. 130,000. That's the vertex. The vertex maximizes my profit. The x coordinate of the vertex tells me how much to charge. Y coordinate of the vertex tells me how much I make. And everything is reasonably consistent with this graph. Estimates of this graph, I put 14.5 here, I sell 8,000. Okay, or 8,500. Gives me an estimate in the ballpark of 130,000. And that's better than the 96,000 we got setting the price at 8 and the 100,000 we got setting the price at 20. Okay. Now, what's our profit function? So now we know everything except we want the profit function. Because of course we agreed the whole problem. Didn't ask it that. That was the problem I did on it. Okay. This is what we're really after. Well, if our cost is $1,000 plus 4x. And common sense, you can memorize it as a definition. Revenue equals, sorry, profit. Profit. What's revenue? That's that $130,000 that we get. For 128,000, whatever it is. It's a revenue minus cost. Profit is a function of X. I'm sorry. The revenue is a function of X. And the cost I just gave you is a function of X. Let's call that C of X. P of X is our revenue function, which is $583x² minus 16,700x minus the quantity 4x plus 100,000. That 4 is so small compared to the 16,000. I'm going to make that 4,000x. Jumbled up there. But if you subtract this function from this function, you're going to get negative 583x² plus 12,700x. And I want another 0 on my cross. Kind of jumbled in there. That's a 10,000. We graph P of X. For zeros, there's our revenue function. We set it equal to 0. The X is going to be negative 12,700 plus or minus the square root of 12,700 squared minus 5,830,000 times 4, which is about 24 million. All divided by 2 times negative 583. I think that shouldn't be 2022. Let me plug in the numbers for just a second. Now again, I'm just going to estimate this. So that's going to be about 150 million minus 24 million, which is 126 million. Okay. You divide this by this, you're going to get about let's say this is about maybe 24 plus or minus square root of this is going to be like 11,500 divided by this. It's going to give you, that gives you 24. I'll say it's plus or minus 24. Okay. But you can put the numbers in. You're going to get something kind of close to this. Use your calculator. That's going to be equal to 3,435. The average is going to be 24. Because you can't say right that high. Okay. Something's wrong. Let me think for just a minute. Okay, I wasn't doubling this. These numbers should have been half. So there it is. Look at this. That tells us where this point is and this point is. And halfway between them should be my vertex. So my graph now is going to look like this. This is about what it should look like. The numbers will be a little different if you punch them in. They'll be in the right ballpark. Okay, so now our graph is going to look like this. We have a y-intercept. Here's our function. It's at negative 10,000. Okay, so we'll put our y-intercept about here. I'm going to float a little bit. This graph is not going to be real well done to scale. So x equals 1.5 should be quite a bit closer to the y-axis. But this is just a schematic showing you what it might look like. Okay. You know your y-intercept is going to be down here somewhere. This point should be over a little further, which would make the graph much steeper going up. We saw something like that, I think, last time. The vertex right here it is. I pointed this out a couple of times. I really want to lock that in. Vertex goes at negative b over 2a. Because this is what gives you that number 12. Okay? Or this divided by this gives you that 12. That should be 12. Yeah, it's a little less than 12. That number's quite a bit off, but that's okay. Axis symmetry is here. And I said that was approximately 12. I like 10 point something or that. But taking the numbers that we have, that's one way to get the axis of symmetry. Another way to get the axis of symmetry is what we did before. Average this number and this number. Okay, we did that with the revenue function. So we could take the number halfway between here and here. Because of the symmetry, these numbers have to be the same distance on either side of the axis. The axis of symmetry. And that's where our plus and minus is. Okay. Plus takes a certain distance on this side, the minus takes a certain distance on this side. Axis of symmetry is halfway between. So now we estimate our vertex is at, well, 12. And R of 12, well, we plug 12 into this mess. Okay. And we're going to get something like 130, 150,000 back. Leave these 140,000. So we got to subtract 583 times 144, which would be okay. Too many numbers in my head. That's like 140,000 there. 144 times this if I have again, about 80,000. I gotta say maybe it's about 60,000. Yeah, that looks like 160,000 with that top line. Like that. Now comparing that with our revenue function. What did our revenue function give us? Here's a maximum. Where in the world is it? I think our revenue function gave us like 130,000, right? Okay. Now, does that make sense? If we subtract our cost from our revenue, Texas 12, that's 48,000, that's 58,000. Subtract 58,000 from 130,000, about 70,000. Whereas this says 60,000, but those numbers are fuzzy because we're doing method. Okay. They should come out consistent. Now, the reason for doing this whole exercise, anybody who's in the support section, well, you can see 3 times now. And if you're not in that section, you probably ought to go back and look at the video for the support course as well, if you really want to understand this. But this model incorporates, again, finding a linear function, graphing quadratic functions, and making sense out of the model. And making sense out of the model is probably the hardest part until you get used to it. So it's pretty likely you're going to see a problem of this nature on the test. So what do we do to solve it? Up with points in the graph and find a straight line. Okay. Straight line tells us how many we sell as a function of what we charge. We could do it like this using the augmented matrix. I did that mainly to illustrate the use of the augmented matrix. And I came out kind of halfway right. I got the right y-intercept with the revenue graph. Somehow the slope got all messed up. So there's something in the calculation here that we'll do. That's not what's important. What's important is use this form or this form to get the revenue function. Well, we chose then to use this form. And get no idea where that whole thing went. Had to be somewhere. Not on the back of this, it's not on the back of that. It didn't wash the board. Anyhow, we found the revenue function, and the revenue function was just we multiply the number we sell by the price we charge. Okay. Again, the revenue is y times this x because we multiply the price by how many we sell. That's how much money we get. from the front and back of this one. Anyway, 2 points give us a straight line. It tells us how many we sell versus what we charge. That's our revenue function. That's a quadratic function we easily graph. If we know how to graph a quadratic function, which is something I guarantee is going to be on the test. It's going to come fairly heavily. Okay. I think it's one of the things we need to focus on in this course. Then we subtract the cost from the revenue function. Where's the revenue function? It's a maximum revenue function. And if I guess what I was looking for was right there in front of it. Anyhow, there it is. So what's the profit? We subtract the cost from the revenue. I adjusted the numbers here a little bit to make it come out halfway interesting. Now, what do we see? If we compare the revenue function, which is right here, and there's a graph. It's not real big, you should be able to see it. We determined that the maximum revenue came when we charged $14.50, let's say. Okay. And that revenue is $130,000. Okay. That's the peak of our quadratic curve. Halfway between zeros is the axis of symmetry. All right. What's the profit? We subtract the cost from the revenue. And when we do, we get all this stuff that I approximated with reasonable approximations, but not impressively accurate. Okay. But you get the idea very simply. You plug the right numbers in and you get a good model, and you determine that this function has zeros here and here, axis of symmetry halfway between the zeros, and when you plug the number from the axis of symmetry into the revenue function, you get a revenue of $60,000. Now, compared to the $130,000, and I said revenue, this is profit function. Right there. I had R there when I meant to have P. Profit. Well, profit function gave us 60,000. Revenue function gave us 130,000 at a higher price. Because of the cost, we had to lower our price in order to maximize revenue. I don't expect you to be able to do calculus and how you analyze all that. It's beyond, well beyond what we need to talk about in this course. But you know, you learn a little applied calculus, you can expand on this model a little bit and understand better how the profit function causes you to shift the price you charge in order to maximize profit rather than revenue. If you maximize revenue, you're still going to do okay, but you're probably going to lose $5,000 or $6,000 for doing that. Okay. If you go over to 14.5, you see revenue is going down a little bit. It's not going down that fast here. It's probably not going to kill your business, but there's several really good dinners that you can treat your family to. Okay, your family for the difference. So again, price you charge reduces because you have to subtract the cost. And of course, when you subtract your cost, you make less money. But all that is very tangible if you think about it. And, you know, should you ever in your future go into business of any kind where you're in control of prices and stuff like that, it's well worth thinking about this model. Okay. Don't put too much trust in it, but get the general idea. If the prices are in this range, that's going to be pretty close to maximizing according to what I think I'm going to sell if I charge this price at that price. Okay. And appreciate the fact that this stuff is really useful. Okay. And all fields. Well, any field that does anything mathematical, pretty much. Okay, we'll continue and do a overall perspective of everything we've covered in the course next week. If you have questions, email them to me in the meantime if they pop up. Bring them to class. They pop into your head during class, ask them, okay?